Hey, welcome back everyone. In the figure above, tangent A is equal to 4/3, AC is equal to 20, and DE equals 8. What's the length of BD? So the answer here is 6. Let's go ahead and explore why. So again, we're looking for BD, the length of BD. And to figure that out, well, it seems that we have similar triangles. Here's what I mean. If we're checking out the big triangle AEC and the smaller triangle BDC, well, what we have here are two right angles that correspond. They share angle C, and that has to mean that A is congruent to B, or the measure of angle A and the measure of angle B are equivalent. So I can already say that these two triangles are similar. And because I know that they're similar, here's what I'm going to do. I see here that AC equals 20. So the entirety here is equal to 20. And we have DE being 8. And we have tangent of A being 4/3. So I'm going to draw the tangent of A in terms of the ratio, because 4/3 is a ratio. So we have this being the 4 side and this being the 3 side. Again, in green, I'm writing a ratio. And I want you to notice 3, 4, the last ratio has to be 5. This is a 3, 4, 5 triangle. If you didn't quite catch that, well, you're going to need to practice with 3, 4, 5 triangles a little more. Because again, 3 squared plus 4 squared equals 5 squared. Or 9 plus 16 equals 25. This is true. That's the essence of a 3, 4, 5 triangle. When the two smaller sides are of a ratio 3, 4, and the hypotenuse is of a ratio 5, that's a 3, 4, 5 ratio. So because I know that, the reason that this is useful is for the following reason. If the 20 is the 5 side, 5 times whatever, in this case 5 times 4, that means that the 4 side is a 4 times 4 and the 3 side is a 3 times 4. Because I know that now, well, boom, this entire thing is 16 because it's 4 times 4. Why is that useful? Well, this is 8, and this is going to be 8 as well to make up the 16 total. Now, the reason that that was important was because this now shows that my smaller triangle, BDC, is half of AEC. It's half because the entirety of EC is 16 and DC is 8. So with that said, again, the side lengths of BDC are half of AEC. Because AE is 12, because 3 times 4, BD is half of that, which has to be 6. Boom. And that's how we know that my answer here is 6 without much math needing to be done at all, without any mental math needing to be done. So I hope this helps out a little bit. Again, in this section here, it's smart for us to tackle problems that have to do with right triangles, 3, 4, 5 triangles, special triangles like 30, 60, 90, 45, 45, 90, all the good stuff. So make sure you're taking note of that and practicing like crazy. That way you can tackle these SAT problems without much trouble at all.